Have you ever wondered how giants like Netflix or Amazon can handle just millions and millions of requests every single second and not even break a sweat? It feels like magic, doesn't it? Well, today we're going to pull back that curtain. We're going to show you exactly how to build APIs that can handle that kind of mind-boggling scale. And the secret weapon for all of this, it's a database called DynamoDB. You know the story, right? Your application is a huge hit, users are just flooding in, but all of a sudden, things start to feel sluggish. That simple little request to fetch some data now takes seconds, maybe even longer. This is the scaling challenge every single successful app eventually faces, and more often than not, it points right back to the database. So why DynamoDB? Well, think about it like this. Traditional SQL databases are kind of like building a brick wall. Every single brick has to be the exact same size and shape, right? It all has to fit into this very rigid, predefined plan. And what if you want to add a window later? You might have to tear down a whole section and rebuild it. But DynamoDB, that's like building with Lego. You can use any shape or size of brick you want, and you can just snap on new, different kinds of bricks whenever you feel like it. This kind of flexibility is an absolute game changer for apps that need to grow and change fast. Okay, to really see how this all works in the real world, let's build a super simple to-do application. And we're going to start with the most important concept in the entire DynamoDB universe: keys. First up is the partition key, and trust me, this is the big one. DynamoDB uses this key to figure out exactly where to physically store your data on its servers. And that filing cabinet analogy, it's perfect. If you're looking for all the files for a specific client, you go directly to that client's drawer. You don't search the whole cabinet. That drawer, that's your partition key. But what if you've got a ton of files inside that one drawer? How do you find anything quickly? Well, that's where the sort key comes into play. It's optional, but it's super useful. Think of it like having alphabetical or chronological dividers inside the drawer. It lets you organize everything so you can pinpoint the exact file you need in no time. And here's the crucial part. The combination of that partition key and the sort key has to be totally 100% unique. Okay, so check this out. Here's how it all comes together for our little to-do app. We've picked username as our partition key. What does that mean? It means all Ali's to-dos are physically stored together, in his drawer. Then we're using title as our sort key. So inside Ali's partition, his to-dos are all sorted alphabetically. This setup makes it incredibly fast to do our main query, find all the to-dos for a specific user. So our app is working great. We can create to-dos, we can find them by user, everything is humming along. But then it happens. The product manager comes over with a new feature request, and our simple, elegant data model is about to hit a major roadblock. So the request is for a new screen that shows every single to-do that was created in 2023. Okay, but wait. Our primary key is username, not year. We can't use our superfast query method for this. So what's our only option? We're forced to use something called a scan. A scan operation is, well, it's exactly what it sounds like, a total brute force search. DynamoDB literally has no choice but to go to the very first item in the entire table, read it, check the year, then move to the next, and the next, and the next, all the way to the end. It's like trying to find a specific sentence in a book by reading every single word on every single page, starting from page 1. It's painful just thinking about it, right? Look, for a tiny table, a scan is fine, whatever. But imagine a table with millions or even billions of to-dos. You are forcing your database to read all of those items just to find maybe a handful that match. This is unbelievably slow, it burns through your read capacity, and it gets very expensive. It is the #1 performance anti-pattern in DynamoDB. You want to avoid it at all costs. So how do we solve this? How do we build this new feature without resorting to that awful, costly scan? This is where the hero of our story arrives: secondary indexes. These are the absolute key to unlocking new lightning-fast query patterns on your existing data, which, of course, means unlocking new features and new value for your users. Okay, so there are two flavors of indexes: local and global. A local secondary index, an LSI, is like adding a new set of dividers to your existing filing cabinet drawer. You're still only looking at one user's drawer at a time, but now you can sort the to-dos inside it in a new way, say by year instead of by title. But a global secondary index, a GSI, is way more powerful. It's like creating a whole new filing cabinet that organizes a copy of your data in a completely different way. For our new feature, a GSI is exactly the tool we need. So to solve our find by year problem, we would just create a GSI with year as its partition key. Now, when we need all the to-dos from 2023, we're not scanning anymore. We're running a query. This is a laser-focused operation. DynamoDB goes straight to the 2023 partition in our new index and efficiently grabs only the items we need. It's fast, it's efficient, and it's cheap, even at massive scale. Problem solved. All right, so we've totally nailed reading data efficiently, but what about when data changes? In modern apps, we often need to react to those changes in real time. And that's where this really cool feature called DynamoDB Streams comes in. Imagine another feature request comes in. Whenever a user marks a to-do as done, we need to automatically send them a little congratulatory email. Now, how can we trigger that logic automatically without having to cram it into our main application code? The answer is DynamoDB Streams. Just think of it like a live play-by-play feed of every single thing that happens in your database. Every time a new to-do is created or an old one gets updated, a new event gets added to this stream. Other services can then just subscribe to that stream and get notified in real time, which opens up a whole world of possibility. And this, right here, is where the real magic happens. We can connect that stream directly to an AWS Lambda function. So a user updates a to-do to done true, bam, that change hits the stream, which instantly triggers our Lambda function. That function gets all the data about the change, and then it can run whatever logic we want, like calling an email service. This decouples our application and lets us build these incredibly powerful event-driven workflows. This is how you build truly modern, scalable systems. Whew. Okay, we have covered a lot of ground today. We've gone from keys and scans to indexes and streams. But if you only remember one thing from all of this, please make it this. With DynamoDB, you absolutely have to think differently. Here's the most crucial point. With DynamoDB, you don't design your table and then figure out your queries. You do the exact opposite. You have to know the questions, the access patterns, your application is going to ask of its data before you even create the table. Your primary key is built to answer your number one most common question, and then you create indexes to answer all your secondary questions. This access pattern first mindset is the absolute non-negotiable key to building scalable, high-performance applications. So as you go back to your own projects, I'm going to challenge you to think this way. Don't just think about the data you need to store. Think about the questions you need to answer. And then design your database to answer those questions perfectly. That really is the secret to building applications that can scale to the moon and back. So what are you going to build next?